All right. So there we go. I'm going to record this. So we're going to be looking at sort of expanding terms. We're going to be looking at some terms that we're going to expand. So we're going to look at like what we call binomials. We call them binomials, meaning two, with bi and nomials. So if we expand these two, we're going to look at an array model as well. We're going to look at that one and how we can visualize that. And then we're going to also look at like the rainbow method of how, I call it the rainbow method because my name's Mr. Rainbow, of how we can expand that and how that works. So from there, if you get this, really, we do one of two things. We expand. So just a quick overview of where we're going with this. So for example, if we've got x plus 2, my Ycom's not on. Come on, Ycom. All right, so there we go. Let's just say we've got x plus 2, x plus 3. If we expand this, that is going to become x squared plus 5x plus 6. That's how I hope you'll be able to do these things. You'll just be able to look at them and basically do them all in one step in your head by the end of it, not straight away. There's a couple of ways we can do this. We can do this as an array model, which is what we'll come back to. So I'm kind of doing our outcome of where we'll go to, and then I'm going to scaffold you guys there. So we have an x plus 2. We have x plus 3. So when we multiply x and x together, it becomes x squared. When we multiply x and 2, it becomes 2x. When we become x and 3, it becomes 3x. When we multiply 2 and 3, it becomes 6. So that's how we do expansion. Now, later on in the chapter, CDE, you're going to have a question that says this. So this was expanding, okay? These are in factored forms. Why we call them factors, I'll explain that a bit later. But we're going to say, hey, from this expanded form, factorize it. So we're going to go that way. So a lot of students find expanding easy, but in terms of factorizing, going from that method to this way is a bit trickier. But you can use this array model to help you. The 6 is obtained by multiplying the two numbers. So we've got the 2 and the 3, so it has to be factors of 6. So it could either be 1 and 6, because it could be 1 times 6 gives you 6, or it could be 2 times 3 gives you 6. It could also be negative 2 times negative 3 gives you positive 6, or negative 1 times negative 6 gives you positive 6. The next thing we need to look at is 5x. Well, they come from the multiplication of the two terms, 2 and x, 3 and x, gives you 2x and 3x. Because these are positive and I add them together, because it's not, I know that clearly my factors need to be 2 and 3 positive, because 2 times 3 will give me 6, and 2x plus 3x will give me 5. So that's how the array model can help. So we can first start off looking at that. We know that that needs to be an x, and we also know that there also needs to be another x as a factor, because x by x will give you x squared when you multiply those together. Then I need two numbers that multiply to give me 6, but also when you add them together, this multiplication gives me 5. So they give me 6, gives me positive 6. But I'm going to multiply this 2 with the x with the 3. So this 2 with the x with the 3 is going to be multiplied by that way, which will give me 2x. And this x multiplied with that 3, so the x with the 2 multiplied by the 3 will give me 3x. Then we add these together, and that gives me 5x. This is called the cross multiplication method. So really, I can see that they're my factors. So therefore, I know my answer, if I need to factorize that, is x plus 2, x plus 3. And that is basically the first 4 chapters that we are doing in a nutshell. That's a really quick overview. We're going to get there. So if you have any questions, feel free to please pop them in on there. I'll hopefully see it pop up. So where we're looking at is we're looking at the multiplication of this. So how does this work? Well, the first thing I'm going to ask you guys, I'm just going to start a new sheet, is, and I'm going to get you guys to get out your workbook for me and work with this today, because I'd like you to take down these notes as we go through to get some understanding of it, and I'll refer you back to it. So if you get your pen out and also, get out some paper that you can do in your workbook, we're going to work through this together. So my first question for you guys, I'm just trying to remember, it was in my lesson plan, is, I think it was like 6 times 8, my memory. Where is it? Here it is. 6 by 8. Must be 6 by 8. Yep, 3 by 8. 3 by 8. That'll do. Let's do 3 by 8. So what is 3 times 8? Well, I mean, Mr. Rainbow, why are we going back here? Now, I'm going back here to try and get you guys to activate your prior knowledge, and then I'm going to link that into how we do it with algebra. So 3 by 8 is 8, 16, 24, right? Like you do counting of 4. So you would have done like repeated addition. How can we represent this as an array? Well, we can actually show that this is the same thing as, 3. We're going to do an array by 8. So you might remember these things back in primary school. Okay, so it's a 3 by 8. So remember, like when we go length times width, it gives us the area. That's 24. So that's why we can use an area model, because when you times 2 things together, it's really the area on that. And that's a really big concept that we just talked about. Like, okay, you probably already know it, but that's how we can represent it, right? 3 times 8 is 24. So my answer for that is 24. Like that's it there. So I'm going to now ask you what is, well, 3 times 2 times 2. Hang on, I think I stuffed that up. Not 2 times 4. I wanted to do, let's go with 2 plus 6. I stuffed that one up in the lesson plan. Well, you do bid maths with this first, right? And you go, well, that's 3 times, well, that's 8, which equals 24, right? Which is correct. But what about if I said I want you to solve this first, like use this first, and then, do the multiplication first, so you don't do your bid maths? And it's like, well, hang on, that breaks bid maths. Well, it does kind of break bid maths, but this is what we call our distributive law. And why we call it our distributive law is because I'm going to distribute this 3 multiplication over each term in the brackets. And that's why we call it the distributive law. We call it distributive law because it distributes the value of the multiplication. Law, and this is not distributive law. Well, you've just done 3 by 8. I'll show you how we're doing distributive law here. So we can show this with an array model. So what we're going to actually do, well, let's just do the maths first. We're going to first go, well, 3 times 2 plus 3 times 6. I've distributed the 3 over every term in the bracket. Notice I say term, okay? 3 times 2 is 6. 3 times 6 is 6, 12, 18. 6 plus 18 is 24. Notice we get exactly the same answer, which we should, right? So let's show this as an array model to make a bit more sense. The first thing we did was just 3 by 8, which is what we did here, right? So I'm just going to do the 3 by 8 again. So the first thing we did was we've got 8 along here. So this is 3 by 8, and that gave us 24. The next thing we did was actually a bit different as an array. We went 3 by, it was 8 the total length, but we had a 2, and then we had a plus 6, right? And then we're trying to still figure out the area. These should be the same shape, by the way, the same size. Ignore this part that I went over with. So if you first did what we did is we first did the 3 by 2, and the 3 by 2 is just this area here. We've just sort of broken it up. That's 6. And 3 by 6 was 18. So the total area for this is still 24. So what we've actually done is we've just broken up the multiplication of that. 3 by 2, which is 6, and 3 by 6, which is 18. hopefully you guys got that one. I'm just going to leave it up there and then I'll move on to the next part in about 5 seconds. If this does seem really easy, that's good. Is there any questions so far? Because I don't really want to move on if you're still not sure. I am going to go through a couple more examples. Let's just see if there's any questions. No, we're all good by the looks of it. Okay, so the next one I'm going to do is we're going to look at 12 times 14. Okay, so just as another example, and again, like this, if you can understand this, you're going to understand the algebra. Like if I get you to understand this concept, moving it to the next concept of expansion is going to be really easy. I learned this from a professor, mathematics professor at university in WA called Lorraine Day, using the area model. And it's something invented back in the 1950s, and they don't use it anymore. And it's just a beautiful, beautiful concept. And I think anyone can actually achieve this. It doesn't matter what level you're at. Everyone should be able to like get the first 2 subchapters correct if you get this. So 12 by 14 is a bit tricky. So in your head, you might be like, well, 12 12s is 144, right? Plus another 2 12s is 24. So what you've actually done in your head is you've really gone with, well, 12, you've gone with 12 12s, which is 144, plus you've done another 2 lots of 12, which is 24. That, I don't know about you, but that's how I do it. Some people might have even broken it down a bit differently, and then you're going to add those 2 together, which then is going to be 168. Some people might have in their head gone, oh, let's go with 12 times 10, and then 12 times 4. So 12 times 10 is 120, plus 12 times 4 is 48. Again, whoopsies, what's going on there? Go, oh, it's just going crazy. All right. 18. Oh, there we go. And 12 times 4 is 48. 120 plus 48 is still 168. So what you did here, either way gets 168. But if you want to look at this, if you did it this way in your head, really what you've done is you've gone 12 lots of 12, which is 144. And now that would be what? That would be the shape of a square because it has the same dimensions. Now that comes a bit later important when we talk about completing the square and perfect squares. That's a perfect square, right? It's like 12 by 12. And then we've got 2 on the bottom. And then that is 24. And then you've added them together and it gives you 168. Over here, if you did this in your head, if you went like 12 by 10 first, that should be straight, by the way. My lines aren't very good. It's really hard to do this on a digi. I'm really impressed about my work, by the way. Just give myself a compliment. So if you went 12 by 10 is 120. Notice it's a bit shorter here because that would be 10. And then this one would be by about 4. So that would be twice as long as the other one. 12 by 4 is 48. Again, it's all about the area. Okay. Now, in terms of multiplication, you can do this. 12 by 10 is 120. 12 by 4 is 48. And a lot of teachers will just show you this way of expanding, and that's how we go about doing that. That's all right. Welcome in, Ria. Tune in with this one. Okay. Any questions on these concepts so far that we're doing? Let's try another one. I'm going to get you guys maybe 124 by 345. Let's look at this before we do something. So please, as I said, copy me down this one. I'll say what's 124 by 100? So if I asked you guys what's 124 without using a calculator by 345, I would imagine a lot of you guys would probably just go, okay, I'm just going to do this, right? And you're going to multiply these. So let's do this together. And then I'm going to show you another way you can do this using the area model. So first thing, you're going to go 5 times 20. No, Mohammed, you cannot leave if the work is too easy. I'm activating your primary knowledge. From here, it's going to get into algebra and it's going to understand the array model. Why? Because I can complete the square using this. Really easy, which is like quite a difficult concept that a lot of year 10 and year 11 students struggle with. So please stay with me. 5 times 4 is 20, and just enjoy it. Like, look at math. It's not about this is too easy. It's about going, oh, that's an interesting way to look at it, because I'm going to throw you an interesting way of looking at it. So 5 times 4 is 20. So we carry the 2. 5 times 2 is 10, so that's just going to be 2, carry the 1. 5 times 1 is 5, add the 1 is 6, right? 620. Then what we do is, for some reason, we add a 0. And if you don't know why that reason is, because we're actually dealing with the 40s. 4 times 4 is 16, carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. Then we add 2 zeros. I shouldn't do lines here because we're dealing with the hundreds, because it's really 300 times 4 would give me actually 1200, right? So that's why we put 2 here. If you haven't realized, put the 1 here. 3 times 2 is 6, plus 7, no, plus 1 is 7. 3 times 1 is 3. Then you add these all up, right? And then the answer for that is 8. That was a 6, right? So it's going to make 15, 17. Carry the 1. Break that down. That's going to be 11, 12. Carry the 1, 4. Right? So that is going to be 42,780. A lot of people go about it this way. I'm going to change it. I don't like doing it this way. I mean, you can if you want, but I'm going to change it up. So I'm going to go a bit different. I'm going to do 124 up here. So I'm going to have a section of 100, section of 20, and a section of 4. Then I'm going to just split this up a bit, and I'm going to change this. Actually, it should be quite a lot longer. And please be taking these notes down, especially you, Mohammed, because this will help you, believe it or not. And I'm glad if you're finding this easy, guys. If you're finding this easy, you're going to find the rest of it really easy when we link it together. So I'm going to make this then 300, this length, about there. I'm going to make this about, maybe about there. And I'm going to make this 40. I did like it down here. 40. And make this 5. So really, this whole thing is 345, right? Hopefully you can see that this whole length from here to here is 345. I've just broken it up, right? And this whole length here is 124. Now, if I asked you guys, hey, what's the area of these two, you'd have to multiply it, wouldn't you? Which is the same thing as this. But we're going to do the area model on this, okay? And then we're just going to add up all the sections. So what I mean by the area model is we're just going to break it up into the sections that we put it into, okay? So we've got, you know, up here, and please use a ruler if you can. Up here, we've got a section of 100, 20, and 4, and we've broken it with 300, 40, and 5. Now, the very first thing you do in your algorithm is you went 5 times 4. Well, 5 by 4 is in this little box, and 5 by 4 is 20. So over here, this is 20. We're going to put a 20 in there. That is 20. Then we still went with 5. We went 5 by 20. 5 by 20 is 100. When we did 5 by 20, we put the 1 in the 100, right? Then we went 5 by 100 is 500. Notice this section adds up to 620. Then we said, oh, let's do the 40s. And we added a 0, and we went really 4 by 4 because it was 16. So if you think about it, it's 40 by 4, which is 160. 40 by 20, or I can go 4 by 2 is 8 and add the 2 zeros as a trick, is 800. 40 by 100 is going to be 4,000. 4,960. Then you do this last section. 300 by 4 is going to be 1,200. 300 by 20, or 3 by 2 is 6. And add all the zeros. I've got 3 of them, 6,000. 3 by 1 is 3, and add the 4 zeros. It's going to be 30,000. So now we just add up all these. So really what we did on our algorithm, this is like 37,200. And we just added these up, right? And this one was 4,960. And this row was 620. And then you can just add these all up. The area of this is 42,780. So it's exactly the same thing. Now, why am I doing this algebra? If I said, guys, what we've actually done is I've created these as factors. These are like the factors along the side. So this is the expanded of it, and I could say like almost factorize it. They're factors. So that's how we get that one there. I'm going to move on because I feel like a few of you guys will have that. Please make sure you've got that like in your book and that makes sense. So really when we talk about factors, so if I say, you know, what are the factors of 12, right? I talk about like, okay, well, that could be made up of 3 by 4, right? Or the factors could also be 1 times 6. Okay, it could also be positive and negative, these two. Now, why are these the factors? Why can't it just be, why couldn't it be, for example, 5? You know what I mean? Because it would be 5 times, that's not a good number I want to use. Why can't it be, let me go to a different number. Let me go to 15, sorry. I'm going to do 15. If I say, what are the factors of 15? The factors of 15, you'd be like, oh, it's 1, 3, 5, 15, right? So if I said to you, why can't it be 4? Because you'd need to multiply 4 by what? Well, 4, 8, 12, 12, 13, 14, 15. So it would be 3 by 3. That would give you 12 and 3/4, I believe. Yeah, so that one there, because 3/4 of 4 would be 3, right? So it would be 4, 12 would give you 15. Now, that is not a whole number. It needs to be whole numbers. So we always talk about that, like it needs to go perfectly into it. Or what I could say is it has a remainder of 3. Okay, I could say it has 3, a remainder of 3. So if it's got a remainder, it doesn't work really well. It's not good. So what do I mean by that? I'm going to show you what I mean by it has a remainder of 3. It doesn't work, and that's why it's not a factor. Why are these factors? Well, because if it's 1 and 15, you're going to have a shape like this. 1, 15. I've got no blocks left over. Could also be 3 and 5. Notice there's nothing remaining. Now, if I want to split 15 in groups of 4, because where does this 3 come from? You got 3, and you got 1, 2, 3, 4. And I know this is really primary school maths, guys, but I'm really just trying to bring it back to your knowledge. Trust me, this, I know it takes a while. This should be 15 blocks in there. I don't think there is. But if I wanted to split 15 into 4, well, my first row, right, would have 4 blocks. Then I would have 8 blocks, right? And then I would have, sorry about it not being the shape it should be. So I'd have 4, 8, 12, 13, 14, 15. So if I wanted to go, well, what is 4 into 15? It would make 3 rows. And sorry, the 4 shouldn't be there. The 4 should be here because it's 4 across. You would have 3 remainder 3 because you've got 3 remaining, right? And that 3 remaining is really over 4 because we're trying to put it in 4. So it's 3 and 3/4. So again, this comes back to the array model. So when we say factorize something, it needs to have no remainders. So factors, and this is a huge concept, don't have remainders. It goes perfectly into it. It's 2 nice multiplications. So this is, again, extending. I'm building up your foundations because all this I'm going to refer back to a bit later on. So now we're going to get into fun stuff. Now we're just going to look at expanding stuff. So for example, if I have 2, and let's just say I've got x. And please write this down. Well, that's 2 multiplied by x, right? Now you can do this number at the front or on the side. It doesn't really matter. You can interchange it. So what I mean by that is that would be 2, 1, 2, and we have x here. So that would give you 2 x's, right? Because there'd be an x here and an x there. So that just equals 2x. However, if we said, well, if I've got 2 and I've got x plus 3 on here as a bracket. Now I've got 2 lots of x plus 3. Well, you've got 2 lots of x plus 3. So what I actually have there is I've got, 2 lots of x's because this would be broken down. So I've got in total 2 x's here, and I've also got 6 here. And I've drawn that the wrong way because 3 should be a lot longer. Okay, another way you could draw it as well would be 2. You could even draw it this way, x plus 3, which I think makes a bit more sense visually, which I probably should have done to not confuse you guys. So if I've got x's here, okay, if that's my length of x, I've got 2 x's here, and 2 by 3 would give me 6. So I've got 2x plus 6. So this expanded would be 2x plus 6. Another way that you can do this, don't forget, that's the array model, would be, and a lot of students do this, and a lot of you guys probably do, would be that. You just do multiplication, which is 2x, and that would give you 6. Now, why am I showing you this? Because it's going to make it a lot easier to undo it. Okay, when it's expanded, how do we factorize it? So how do I factorize this? I've got to take out a common number, and my common number in here would be 2. Okay, so when we go back, but we'll touch on that one a bit later. So that's how we factorize when there's something at the front, like a number out the front. We just multiply everything on the inside. You can use the array model if you like to help you get there, and then you can just write it's literally shows you there, or you can do this method too. I would personally like you to do both, and that's pretty good. Now the next option is we're going to just do another one. I'm just going to step it up a bit. If I've got x plus 3 and x plus 4. Now, let me just ask you something. If I've got 3 plus 2 by 3 plus 4, the very first thing you do is 3 by 3. We just look at that 3 by 3. That would be 3 by 3, right? And what is that going to make? That is going to make a square. So we could call that 9, or we could call it 3 squared. So then you've got, let's do the first one up here, 3 plus 2. Then you're going to have 3 plus 2, which will give you 6. Then you're going to have this 3 plus 4 down here. 3 by 4 is going to give you 12. And 2 by 4 is going to give you 8. Then you can add these all up. So it'll be 9 plus 6 plus 8 plus 12. However, what I really want to focus on is when you're timesing the same thing, it makes that number squared, right? So really here, when I go x, we're going to do x plus 3. And x plus 4, and some people get a bit lost here. Some people just know it as a rule, but why we actually make a square? Why do we call it squared? Because when you multiply the same thing together, it's actually going to make a square, and that's why we call it x squared. So when you do x by x, you're going to get x squared. Then you're going to do, because this is the x plus 3, then we're going to use this x and multiply it by that 4. When you do x times 4, you're going to get 4x. Then you're going to go start working with this 3 because you haven't distributed this 3 across this. Now I've distributed this x across these terms, but now I've got to distribute this 3 across these terms. 3 by x is 3x, and 3 by 4 will give us 12.
Wouldn't it be 4x, not 4 squared?
Yep, that is 4x there. Did I say 4 squared? 4x, yep. Good question. So that one's 3x and this one's 12. So now what I need to do is I can simplify and collect my like terms. So that's going to be x squared plus 7x plus 12. So actually in my head, I kind of do this when I'm factorizing. Because if I said to you guys, hey, you know, factorize this, you'd be like, oh, I've got to get this to go back into that. Like expanding is easy. This is a bit tricky. But what I picture in my head is I have an x squared here, right? And down here needs to be 12. Right? And this 12 needs to come from factors that make the sum of this one because this is positive. So if this is plus 7, oh, well, the 12 would have to be a 3 and a 4 length. So that would be like, for example, or yeah, sorry, it doesn't matter which way. So that's 3 and that's 4. Keep it consistent. So let's just say that's 3 and 4. 3 and 4. So therefore that would be 3x, that would be 4x. So that gives me my 7x, and that's x plus 4. And that's x plus 3. And that's sort of where we're going in the subchapters. So that'll be x plus 3 because that gives you 3x in this area. Sorry about my scribble. And this will give you 4x in this area. So again, this array model really helps us more with then going from here backwards rather than expansion. So that's why I'm encouraging to introduce it. especially when we get into more complicated ones like completing the square. So I'm actually hoping to get through most of you guys through the whole chapter 8, even the extension stuff, so getting you into year 10. So you've already got some good skills on that. And if we don't get there, that's okay, but I'd like to sort of move along a bit quicker. But if we don't and we need to hold back, we can. So hopefully that expansion helps you guys a bit with it. So one thing to note, though, it does get a little bit different. I'm just going to change up a few things. So if we've got x, I'm going to speed it up, plus 3, and let's look at x minus 4. This changes it, okay? So this would actually make it an x squared. So you're still going to have your x squared in here. That's going to give you 3x. This, though, is going to give you negative 4x, right? And this is going to give you negative 12. So you're actually going to get a sum of x squared. These added together will give you minus x minus 12. So that's how it will be simplified. When you expand it, though, it's going to give you, x squared plus 3x. So it's actually going to give you, x squared. I should have written this first. Minus 4x plus 3x minus 12. So when you do this, if I asked you guys to factorize this, because this is a negative number, I know that one factor is going to be positive and one factor is going to be negative. And then when I add them together, it needs to be negative 1. So I know that they're also 1 apart. So 3 and 4, it tells me. So that's why I really like the array model. It helps us get us there. So just be careful, like when you've got a negative and positive, it will change some things, and just be careful of those numbers when you're multiplying. You can just multiply it out and you're just distributing each number across. If you've got x minus 3, x minus 4, that's going to give us a plus 12, right? Because that's going to give us plus 12. We're also going to have an x squared in the corner. Then I'm going to have negative 3x and minus 4x. That gives me minus 7x. Now notice, if I had positives in here, that would give me x squared plus 7x because of the 3x and the 4x, and plus 12. Notice it gives me exactly the same term on the end, because a negative times a negative gives me a positive, and a positive times a positive gives you a positive. This number gives it away, though, in the middle when we're trying to factorize it. Because that's negative, and that's positive, I know these both need to be negative. Because this is positive here, if I'm trying to go backwards, I know they both need to be positive, because that's positive. If this is negative on the end, then you know one of your terms has to be negative and the other one has to be positive. If this is positive on the end, I've got two options. It could either be negative and negative, because I know in this case it has to be negative because that is giving me a negative, or it can be positive, and then I use this middle number to look at because I know that is positive, because this would give me, like, it has to be positive plus positive because of this one, because this is positive. So it'll either be two numbers are negative or two numbers are positive, but if I look at this one, it tells me they're positive. This is positive, so it's either two numbers multiplied, because the only way you can get that is from this array here, right? Sorry, that's the negative one. So hopefully that makes a bit of sense. So that's why I'm trying to use the arrays to help you guys understand where we're at and where we're going. And my pen's gone all weird again. So yeah, that's sort of where we're going on that one. So I'm going to leave it there. That's pretty much most of the questions. So this is the array model. So I was going to show you guys what you can pull up. So again, this would be like x plus 6, x plus 3, and you can see that makes x squared, 3x, 6x, 18. So this would be x squared plus 9x plus 18 altogether. If we change this, to this, if this is an x plus 3 and an x plus 3, we call this a perfect square. Why? Well, because it makes a perfect square. Okay, how you'd write this would be, and this is probably getting onto the next chapter, 4b, so why not 8b? Let's do that. If I write x plus 3 all squared, that just means all this is multiplied by itself twice, right? So it's x plus 3 multiplied by x plus 3. And we call this a perfect square, or because it makes a square. And you're going to expand it the same way. It still gives you 9 here, 3x, 3x, and 6. So when you expand these, they can make a perfect square. So that's sort of where we're going. We also have difference of perfect squares. Difference of perfect squares are different. So this is a perfect square. And why we call it a perfect square is because it makes a perfect square. So please copy this one down, and you can write, we call it a perfect square because it makes a square. So this needs to be a square shape, this one. And then we're going to go square. That's why we call it a perfect square. So x by x, and that should be straight down, will give you an x squared. And x plus 3 would give you 3x. That would give you 3x, and this will give you 9. Now, how do I know when I'm dealing with a perfect square if I've got to factorize the other way? Well, this would give you x squared plus 6x plus 9. Well, what you'll realize is that the two numbers, it's going to be x plus 3 by x plus 3. So it actually works out. And we call that a perfect square. There's another one, let's zoom out, sorry, that we call difference of two squares. Or is it difference of two squares or difference of perfect squares? I can't even remember now. So the other one that we call is, it is different. We're going to look at this one. So the next subchapter, perfect squares and difference of perfect squares. Difference of perfect squares, that's it. I just call it difference of two squares. The difference of perfect squares. And now we're moving straight into the next subchapter because it's all the same concept now. Perfect. And the name tells me everything. It's a difference of perfect squares, but there's two. This is just a perfect square. That makes one. Let's look at why this is a difference of perfect square. So when it's a difference of perfect square, you'll find that one is positive. Whoops. Let's say it's plus 3, and the other one's going to be minus 3. X minus 3. Now, the x's need to be positive. And I'll show you why it's that. If we do this, let's create an array for this. If we expand this, right, it's going to be x squared plus 3x minus 3x plus 3x minus 3x minus 9. So that is going to leave me with x squared minus 9. So you're going to notice that that is a difference of perfect squares. Notice the x's have disappeared because these two cancelled each other out. Why do we call it difference of perfect squares? Well, you need an array model to understand this. I actually never knew this when I was in high school. I wish someone showed me. So we've got x plus 3. And we're going to do x minus 3. When we go x by x, let's just draw this. This will again be a square because the size is the same, right? I mean, absolute value, which means excluding negatives or positives, the absolute value of this is x plus 3. So, I mean, the 3, even if it's positive or negative, is going to be the same length. So that's going to give me an x squared. Over here, this is going to give me, and this is why I want you to stick around, Mohammed. Hopefully you haven't seen this before. This is going to give me minus 3x. And this one here is going to give me 3x, right? Now, this should be a square here. It doesn't quite look square, but 3 by negative 3 would give me a square, right? That is going to give me negative 9. Now, if you think about it, this is going to cancel out, right? That is going to cancel out with that one. Would you guys agree? So what you'd be left with is your x squared and another square here. And notice your numbers are always down here. Why? Because this would be an x and that would be an x. And then you'll have a 3 by 3 square here. So notice that this negative 3, that's x. Why we call this difference of perfect squares is because this is a negative, right? That's a positive. It's the difference of that and that square. And there's two perfect squares, hence squares. Difference of perfect squares. They're perfectly square. It's the difference between them. That's why we call it difference of perfect squares, which I think is just really, really awesome. They do cover this in pre-methods. So completing the square, I can show you guys that quickly, which is really, really, really easy. That is difference of perfect squares. So please make sure you copy that example down if you want to be extended even more. So why does this help? So the hardest thing probably in methods for kids to do is to complete the square. So for example, if I've got x squared plus 6x plus 1, and I want to complete the square. Well, the first thing I've got to recognize is that I want to make it into a square. So if I've got 6 x's, well, I'd have to halve that, right? Because I want it to be a perfect square. So it would have to be x plus 3. And that means this would then have to be x plus 3, right? which is x squared. This would give you 3x. And this would give you 3x, right? Because why would I have it? Because I'm trying to complete the square. And we do this for graphing later on, but let's just look at the algebra. So if you've got 3x and 3x, but I've only got 1 in here, right? If I've only got 1 in here, I mean, I need 9 because you can see that 9 is going to fit in here. So what I've got to introduce to this equation to complete it is I need to add 8 more. But if I add 8 more in here, which I'll add in here, which now gives me 8, right? I've just added in 8. So I've just now got 9 units in there. So that has completed the square. I've added 8. That's completed the square. So that actually gives me, if I factorize it, as x plus 3, x plus 3, which we can say is x plus 3 squared. But because I added 8, that's not really balanced. So I need to take away 8. So that would complete the square by adding 8. And why we call it completing the square is because I added in these 8 to complete a square. I made it a square, right? I mean, we're all talking about squares here. There's nothing more to it. So now I'm going to minus 8. And then what this tells us, if this is an equation, this will then, and this is what we're going to talk about later on, this will then tell me a parabola. That tells me how far it's moved left or right, which has been moved -3. That tells me how far it's moved up or down, which is -8. So, and then I know it's a parabola, so it's going to look like this. And I know its turning point occurs at -3, -8. And that will then, and that's why we complete the square, because it helps us graph it. That's kind of going through year 10. My year 11 struggle with that too, some of them. If you don't get it this year, that's okay, but you need to get it by next year. Hence the arrays are really good. And I think like understanding like, why do we call it completing the square? Because that's what you're doing. You know what I mean? And if people know how to complete the square, they'll see it as a rule of this, b on 2, all squared. Why is it that? Because what you're doing is you're halving b, right? You're halving b. If you halve b, you've actually halved this section. And then you square it, well, because once you've halved it, you need to add 9 in. So you could actually add 9 and then take away 9. And then you take away the 1 and sorry, add 1, which would leave you with -8, but it doesn't matter. I've just borrowed the made it into 9. So that's how you can also get it too, because what you're trying to do is complete this area. You're trying to make that so you can make it a perfect square. And why we call it that is from this array model. And I think it just absolutely rocks, this array model, because you can use it to justify what you're doing. Otherwise, it's really conceptual. So I hope that helps. I know I took a lot of your time, but really what I've done here is covered the whole subchapter. That's pretty much everything that you're going to get in here. So, I mean, we'll expand and unpack it, but that is everything that we've explained to you pretty much in an hour. That is the whole subchapter. So if you've got everything in there, you're going to smash it out. So good luck. I'm here to help you. I really want to be helping you guys. So if you're not sure on any of these concepts, as soon as you're not sure, please sing out. I'm going to put up a meeting, jump on. I'm going to work through a few questions with you, especially if you're a student that wants to go on with pre-methods, because if you don't get it, you know, you're going to struggle next year. If you get it this year, and we've got the opportunity to work really closely, if you get it this year, you're going to smash it next year. And I really want you guys to, like, you know, go in strong, feeling confident. Because I find if you don't get it this year, you sort of, and you can pick up next year, but if you don't pick up next year, then you're not going to cope in year 11 at all. So yell out, try and understand both ways. Even if you kind of know how to do everything, try and be open to understand a bit of the array model as well, because that will help us then when it comes to application questions. Because the application we deal with a lot of time with squares, and it will all come together. So what we're trying to learn now is the algebra. So then we graph it. So it's very similar to linear. So we learned like how to manipulate equations and write it in terms of y equals mx plus c. So then we could draw the graph. So for example, what we're going to do this time, we're going to look at, like, you know, how we do things like this to complete it, to find the turning point. Similarly, my original equation for this was x plus 6x plus 1, which I chose a really shonky one. But if I want to find these y-intercepts, I need to factorize this, okay? Which is not, this isn't a good one, but really, let's just say we have a different graph, x plus 6x. Let's go with the factors of that would be 2 and 4 plus 8, okay? So if I want to factorize that, that would be x plus 4, x plus 2. I'm really doing bad at this. I need to take this all back. Let me start again. If it is x squared plus 6x plus 8. I'm just trying to link it all together. That would mean factors of x plus 4, x plus 2, because when you multiply that, that's going to give you 8. X by 2 is going to give you 2x. 4 by x is going to give you 4x. That's the 6x. Notice it's positive, positive, so I know they both need to be positive on the inside. That then tells me that my x-intercepts are going to be at -4, -2. You don't need to worry about this now. My y-intercept has to be at 8. So I know my graph is going to be like this, okay? If I wanted to find the turning point of this, I'd need to complete the square. To complete the square of that, I'm going to need to add 1 and take away 1. Why? How do I do that really quickly? Because I actually pictured it in my head. I've got an x square. I know it's 6x. That's going to be 3. That's going to be 3. That's going to give me 6. That's going to give me 3x here. That's going to give me 3x here. 3 by 3 would be 9, but I'm 1 short of 9, so I'm going to add 1 in, right? So that's going to give me x plus 3 squared. So the equation is going to be x plus 3 all squared. But I've also got -1. So that gives me a turning point at -3, -1, and that is it. And that's how you graph them. So that's where we'll be going later on. Obviously, I've had many years of experience, so do not worry. I'm going to stop the recording there.